MSE 4506 nano scale material. Okay. So this class, this course introduce students to the field of nanoscale material. Okay. Nanoscale material have chemical and physical properties that are significantly different from those of bulk material. The course will cover the structure and property of variety of nanoscale material. Okay. In addition, it will cover the synthesis and assembly of nanoscale material based on top-down and bottom-up approach. The major potential application of nanoscale material will be discussed. Okay. For student duties, the class attendance must be greater than 80%, and you have homework 70% and presentation 100%. I'm not sure what it means 100% presentation, and assignment writing 100%. Okay, but for us assessment, so midterm exam will took 20%. Okay, 20% for midterm exam, 30% for presentation and homework 20%, and final exam will be 30%. Okay, so the final exam at the syllabus here only 30%. Yeah. For assessment, you have midterm 20%. So I think it should be a presentation and homework and midterm exam. I don't know. It should be we should do as one. Is this okay for midterm exam? And homework and presentation do as I will give you some topic, okay, and the class will divide into I see here the class have 15 students, so it should be divided to 5 groups. So each group have one topic, so I will let you 8 week for preparation. So after that, it will present the topic. Okay, so the presentation will accept as midterm breaks, presentation, and homework. Is this okay for do all of this as one work, or you want to separate midterm break, presentation, or and homework? Do you want to do only one presentation, or do you want to separate? Do you understand? We have 3 different tasks here. One is midterm exam. Okay, so I want to use homework and presentation and midterm exam as one. Okay, is this okay? Anyone? No idea? Chami?
That means we just have to do a presentation, replace to midterm exam and homework, right?
Yeah, as one task, one task for assessment. You don't have to do homework, and you don't have to do homework to submit. It means the presentation is mean also homework already. So I give the topic, so you have to study at home yourself. So it's also considered as homework. Okay, so you later you present, so that score will you for the assessment, midterm assessment.
Okay, I think it's fine.
Okay. Other student, do you understand? We have Lữ Duy Nam, Lữ Duy Lam.
Yes, I understand.
You understand, right? Okay, so I will give you a topic. Okay, so you will do homework and prepare for presentation. Okay, so that's a presentation score will use as a assessment for midterm. Okay. Okay, one more thing here, I also want to tell you or discuss with the class. Okay, actually, for the final exam, okay, as I discussed with Dr. Bing and Dr. Bang, maybe the final exam we will do as a multi choice. Okay, so this we will plan to assess the final exam. Is this okay? So I think it will easier for us to do multi-choice. Okay.
Okay. Yes.
So for multi-choice exam, so you also have to a little bit different for you have a little bit different technique for study. Okay. So you also have to ask yourself, ask question by yourself, because later the teacher will ask a lot of questions. Okay, so you have also have to ask questions by yourself and answer. Okay, so during the class, okay, I will give you some example how we can do the multi-choice. Okay, exam. Okay, so that is thing. Okay, so okay, the final exam here already 30%. Okay. Okay, we have the course or material here, the textbook. Okay, here we have several books for the reference. One is Nano skill material in chemistry. Okay, really in 2004. Okay, and the second one is processing property and potential application. Okay, by Clark Seacock. Okay, ebook published in 2002. Okay, and actually I also you have another book also. Skill material. Okay, I remember. Please wait for a moment. Just for a moment. Okay. Nano skill material. Okay. Okay, this book. Okay, this is the book I use okay, for the lecture. Okay, please capture this book. Okay, nano structure and nanomaterial synthesis, property and application. Okay, the author is Gao Kao. Okay.
Oh, sorry, we cannot see the
Oh, you
this
cannot
the
see
textbook.
the textbook. Okay. Can you see?
Yes.
Okay. Okay, this the main book I use for this course. Okay, nanostructure and nanomaterial synthesis, property and applications. Um, the author is Wu Zhangkao. Okay, this is Imperial College Press. Okay, this is the book. So you can capture this book. Okay. Okay. So I will go to the course content. Okay. Here is the syllabus of this course. Okay. Can you see?
Yes.
Okay.
Yes.
Okay. So this course will cover for the first chapter. We will study about nanoscale material synthesis and characterization. Okay. Is including chemical synthesis of nano particles, 0D nanomaterial, and the second topic will semiconductor and semiconductor oxide nanowires and nanotube growth by simple thermal evaporation methods. Okay. The next topic will nanostructure film by sputtering and chemical vapor deposition. This is for 2D nanomaterial. The next topic is characterization techniques, uh, fraction and microscopy techniques. Okay. That is for the first chapter. And for the second one will be a nanomaterial and structure. So actually this topic will cover some special nanoscale material. Okay. The first one will be a nanoscale carbon, nanoporous carbon, uh, fluorines, carbon nanotube, and graphene. Okay. And nano silicon metal nanoparticle. Okay. For the third chapter is will be property of nanomaterial, optical property of semiconductor quantum dots, um, magnetic property of nanocrystalline material. But I think this kind of arrangement not, I think it's not very well. It should be in the first chapter. But anyway, this syllabus already approved, so we have to follow this syllabus. Okay. First, select the application of nanoscale material and their health impact issue. Okay, so this is all the topic for this course. So I will in charge the first and the second topic. Okay, the first and second topic. Dr. Bing will in charge in the third topic about property of nanomaterial, and Dr. Bang, okay, will in charge some selected application of nanoscale material and health impact issue. So this is a plan of teaching this course, okay? And so you will have actually 7 weeks to prepare the presentation, okay? So no, 8 week. So the week 9 and week 10 you will do a presentation, okay? Week 9 and week 10. So please next week give me the group of the class. The class will be divided into 5 groups. So the monitor of the class, please give me, okay, the group, okay.
Okay.
Okay, so we have 5 groups, okay. Sami, you got it right?
Yes, I see.
Okay, 5 group. Okay, so next week we. Okay, everyone understand? So for the presentation. So I repeat again. So you will have 8 weeks to prepare the presentation. You will present the work at week 9 and week 10. Okay, week 10. Okay, yeah. Okay, so that is about the course and the homework and the assignment and the final exam. Okay. Okay, now we go to the lecture. Okay, this is the course. Okay, nanoscale material. Anyone can see the slide?
Yes.
Yes.
Okay, if I hope it's fast or it's not clearly, so please ask me again. Okay. Okay. Or if you have some question, you can interrupt me to ask also. Okay. So first we will go to introduction of this nanoscale material. So for this lecture content, we will cover the definition of nanoscale and nanomaterial, and we also classify nanomaterial, and I also give you a briefing of formation of nanoscale material, and also give you a briefing on property of nanomaterial. So this is the topic of this lecture. Actually, property of nanomaterial material here, I just give a briefing on property. Later, Dr. Bình will teach you in more detail on this property in chapter 3. Okay. Okay, so for nanomaterial and nanotechnology, okay, you nowadays you can see everywhere, okay, almost everywhere. When I also study SOS now in 1904. Okay, I'm sorry. I'm sorry. Okay, we go back to our lecture. Actually, in around 2000s, when we talk about nanotechnology or nanomaterial, it seems to be something very new, okay, very strange. It seems that something yeah, very new about nanoscale material, okay. But today, nanoscale material or nanotechnology, you can see it and you can feel it. Okay, for a very simple example, I still remember one about Japanese experts. They come to Vietnam to clean our river. We call, I think you know, is Lake River. So they use nanotechnology to clean the river. Okay, so that's you can see the application of nanotechnology nowadays is spread very widespread over the world, and also not is seem like a mystery technology anymore. Okay, and also I just this one newspaper, they talk about the clothes using nanotechnology. For example, you if you drink coffee, if the coffee drops onto the clothes, okay, so it doesn't matter. You don't have to worry about that, because the coffee is doesn't penetrate into the body. Okay, you not stay in the clothes. Okay, you don't worry about that, because the new technology can by applies nanotechnology. Yeah, you can have prevent the penetration of drop water, and you don't have to worry about the works of this dusty. Okay, that's also a simple example of application of nanotechnology today. And of course, for higher, maybe you talk about something is bigger like a quantum computer. Okay, it's also using nanotechnology. Or you also heard about the processor chip of the computer. Okay, nowadays the computer you want is works more power. Okay, more power, but the laptop or computer you want to is smaller and thinner, but it's still stronger. So it means that the chip have to be much more stronger, but still thin. So you know that in the motherboard of the computer or the laptop, the space limits. So if you want a more stronger or powerful chip processor, it means that in one small space you need to have more transistor, million transistor. So it means that all these have to divide, okay, divide this transistor into a nanoscale. Okay, so I'm sure, oh, no, okay, or may you also heard about nano, okay, nano chip, yes. So that is nanotechnology and nanomaterial. Of course, for silicon, they use as a nano chip, okay. Now it reached the limit station, so people have to find another nanomaterial to replace. Okay, now it's already the minimum the minimum refined that scale. Okay, I know that scale already refined to 2 nano uh, 2 nano scale. It cannot be to device smaller. Okay, so that is the limitation of this material using for the processor chip in the computer. Okay, especially for a supercomputer. Okay, so we have to have much more power. Okay, so we the nanotechnology, okay, can expect to solve that problem. Okay? And of course, today you also heard about the, like the battery, okay, using for the electric car, yeah, or even electric bus. So they require the battery have uh, more power, okay, capacity, and have to charge very fast. So that also can be applied to the nanotechnology and nanomaterial can solve that problem. So that's some application even in the health. Okay, the nanotechnology also have a strong impact in the technology to treat the human health. Okay, so let's in application we will tell you in more detail. Okay, for nanotechnology, not only in top university in the world they have or they study about nanotechnology or nanomaterial. Nowadays, nanotechnology or nanomaterial in over the world. For example, in Vietnam, we also have many university or many the institutes, research institutes also interested in nanomaterial and nanotechnology. Okay. Okay. And talking about nanomaterial and nanotechnology, you can see that is involved to material mechanical system. Okay, atomics, of course, because this nanoscale is relates to atomic. Okay, molecular. Okay, assembly of quantum property. Okay, development nano system, nanoscience. Yeah, and nanotooth. Okay, So all this one involved to nanomaterial and nanotechnology. So nano technology and nanomaterial is become very important technology today. So it's a promise technology. Okay, it can have people to solve many problems, including health, energy, environment. Yes. Okay. So the question is here: what is the nanoscale? Okay. So for the image, if you consider our Earth as one sphere, okay, a giant sphere with a diameter of about it is 12,000, yeah, 12,000, okay, 12,000 kilometer, okay. So if you scale down, okay, our Earth uh, about 50,000, 58 million times. So it can become a small like a ball. You can see here, if you scale down, okay, about 58 million times. So you can have one ball, okay, football, okay. Yes, you can touch it, but further, if you scale down further the football, okay, also by 58 million, you can get a very, very small, extremely small a sphere or particle is 3.8 nanometer. So this is how the nanomaterial scale, how small it is. So for our definition is nano meter is equal to 10 power minus 9, okay, meter. 1 nanometer is equal to 10 power minus 9 meter. So this is about nanoscale. It's extremely small, okay. So it's equivalent to atomic scale or molecular scale. So for the image about nanoscale, so we have something to compare here for you. Okay, one is for natural things, and one is the right side. The right hand side here is something that's a human made. It can be from micro to nano scale. Okay. Mm. So for natural things, okay. I'm sorry, a little bit. This stuff. So sorry. Okay. Sorry for this for interruption. Okay. So for natural thing from micro scale to nano scale. So here I'll give you some example. Okay, for the image. Okay, first one example is about ant. Okay, the animal you can see. Yeah, you can see every day in the house or somewhere around the living house. Okay, so the ant about the dimension is about 5 mm. Okay, 5 mm. So this is in and of course this one you can see by the naked eye. Okay, and for the fly ash, for example, you burning wood. Okay, and the fly ash will flow up to yeah, to sky. Okay, you also can see by the eye. Okay, so the diameter of this fly ash is about 10 to 20 micrometer. You still can see, and the human hair about 60 to 120 micrometer. Uh, okay, you also can see by the naked eye. Okay, so that's in still in micro scale. Okay, even in the trace blood cell. Okay, have a smaller, but it's about 7 to 8 micrometer. Okay, this is, of course, this blood cell you may not see by the naked eyes. You have to use microscopy. Okay, it can be optical microscopy. Okay, you can see it. You don't have to use like electronic microscopy. So for a smaller scale, you cannot see even by using optical microscopy. For example, in enzyme, okay. Also enzyme, you cannot see it by optical microscopy, or even a smaller enzyme here about 10 nanometer, and even a smaller scale. Here is DNA. Okay, for DNA. Okay, it have scale is about 2 to 0.5 nanometer, is equal to the atom scale. Okay, you can see here the atom scale of silicon is about zero point 0.1, yeah, 0.1 nanometer plus the atom. So it's very amazing that the human can create or make some equipment or some tool that they can see to very or extremely small thing like atom. I think before they can make this kind of tool, TEM, okay, TEM, transmission microscopy, to observe this kind of extremely thing. So people maybe just image about the atom, even though they said atom is like sphere, like a ball, extremely small, about 0.1 nanometer. So before that, we never seen, okay, in a real about the atom size. But today, okay, with the development of technology, people can make some extraordinary tool, okay, that can observe very small, okay, small thing as a nano, or even smaller as atom. Okay, we can observe the atom. Yeah. Before that, we just the atom, we just make is simulation. Okay, it's not in real simulation. Okay, yeah. Uh, that is for the natural thing. Okay, and how the people can make how small thing, okay, people can make. So the first thing people can make is very small. Here is head of a pin about 1 to 2 mm. Is quite small thing already. And for us, people also can make some a smaller device or machine. For example, here people can make micro to mechanical, okay, devices, okay, about 10 to 100, okay, it means 0.1 millimeter, okay, very small. You can see here, a very small machine, okay, and even people can make some tool or some equipment can observe smaller scale. For example, they can make STM apparatus, this kind of surface transition microscopy. It can observe the surface of the thing with us, the nano scale material, even at a very at the atom. They can. So here is one example of how they can observe the surface of material at nanoscale material. This is they can observe at the atom scale. Okay, so this is how the ion. Okay, they can observe the ions atom arrange. So it's very amazing. Okay, people can the work people can do it. Okay, that's very small. Or even now, we also for material we can synthesis at very small. For example, nano tooth, we can make something like very small with diameter about one nanometer. Okay, very small. Okay, or we also can make uh, 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 something like a ball, football. Okay, what we call is a buckyball here, very small at about 1 nanometer. Okay, okay, we can make a very small ball. It have the diameter about 1 nanometer, 1 nanometer. So this is something or some image for you about micro and nano scale. Okay, so here, yeah. So I hope you can image what is nano scale. Of course, maybe it's still difficult for you to image how small nano scale. But if you further work or do research on this nanoscale or nanoscale material or nanotechnology, so you will get used with it. So you can feel how much, okay, how small this material. So you can feel is one nano small or 10 nano, how 10 nanos meter small, or even 100 nanometer, how is small. You can feel it. If you can do research on nanoscale material, you can feel it. Okay, but now maybe it's not easy to feel how small of nanoscale material. Okay. Okay, so what is the definition of nanoscale material, or yeah, or yeah, how is relates to a nanoscale material? Okay, the nanoscale is the scale of atom and molecules. Molecules. It is the fundamental building block of the material world. It means we can consider the nano scale is the smallest thing to build the material. Okay, the object. For you can easy to understand. Okay, for example, you can see how to see. You can see the sand is have small particle, right? If you mix it with the cement, so it after it becomes the solid, you can see it one object homogeneous. It roughly you can call it a homogeneous object. So it means that this object is uh, uh, created by very small particle, right? If you break down that object, okay. So here we also can say that the nano particle. It can be the fundamental building block of the material world. Okay. Yeah. Yeah. So for nanomaterial, the nanoscale mainly means just length, the size, diameter, the edge. Yeah, is measurable on the nanometer scale. Okay. Okay. So this is for nanoscale. So here, for example, here from atom and molecule, you can build a nano scale material. And of course, from nano scale material, you can use the bulk or the solid, okay, solid object, okay. And of course, for you here, you can easy to image, okay. This is for the one gold bar, okay. You can make a slide it down into very small particle is to nano scale material. Or in other words, you can combine all this nano material nanoparticle can be combined and it make one solid. Is a solid, or we call it a bulk material. Okay, bulk material. And you can see here is very nice nanoparticle human can make here. It nanosphere, nanoshell, nano dross, okay, and nano case, and even we can make it in a nanostar. Yeah, it's very interesting. Okay. And so for more detail, so we will define, okay, what is nanoscale material. So just a previous slide, I just talked about nanoscale, but now we have to define what is the nanoscale material, okay, or in other words, what material we consider as nano scale material. Okay, so here we define as the substance, okay, have at least one dimension is less than 100 nanometer. So we will consider that material is nano scale material. Okay, have at least one dimension. For example, if you have one nano wire, okay, this can the line is can be several micrometer, but if the diameter is less than 100 nanometer, is still considered that wire is nano material. Okay, so that's why the definition here state just, okay, at least one dimension is less than 100 nanometer. So we can consider that is nanoscale material. Okay, for more exactly, most of definition place nanomaterial between the approximate limits of 1 to 100 nanometer. Okay, so this is a nanomaterial range. Nanomaterial range. So when I talk about nanomaterial, so you have to understand that this material have at least one dimension E, or in between, fall in between 1 to 100 nanometer. Okay, so this is the definition. Okay, so even you go to USA, you go to Europe, or you go to Japan, and everywhere in the world, so you have to understand when people talking about nanomaterial, so you have to understand that the dimension of that material falling in between 1 to 100 nanometer. Okay. So nanomaterial possess different property compared to macroscopic material, or we call it a bulk material. Okay, so for material have dimension in from micrometers, and normally we call it bulk material. Okay, so when we talk when you read some paper or you read a book, people write about the bulk material. It means that the material with scale in a micro scale. Okay. Okay, so again, nano material possess different property compared with macroscopic material, or we call it bulk material, which are built up from the same atom or the same compound. For example, aluminum or copper. Okay, also building if nanoscale aluminum will have the property different with the micro aluminum, even it's the same material. Okay, even it's built up from the same atom, but the property of nano aluminum particle and the property of micro aluminum material particle also are different. Okay, yeah, so why different? So we will study in the next slide. Okay, so here is some image, for example, in a nanoscale material. So this is a very nice buckable. Okay, this is about carbon. Okay, carbon. This we will learn it in chapter 2. Okay, and here some we call it nano rod. Okay, nano rod. Okay, this have 1D. This is 1D material, nanoscale material. 1D nanoscale material have diameter in nanoscale. Okay, each line can be in micrometer. So here we call it nano scale material. Okay, for nano material versus bulk. Okay, so the most important question is why material on this scale from 1 to 100 nanoscale are distinguished from the bulk material. Okay, so the question, yeah, why is different? Okay, why nanoscale material possess a different or we can say it's a special property. Okay, so the first difference is come from large size different behavior in collision with atom. Okay, this is first thing is come from the size. Okay, come from the size of the material. Okay, so as you know that in scale atom, for example, in atom, the behavior collision in atom is will different in the group of atom, and even it will be different and hundred or thousand atom. So it means that when the material become the size become bigger, so the way of atom in that group, the interaction or collision in that material will be different in a small scale. So that will lead to the different property. Okay. So we will study more detail about this behavior. And the second one is the effect of quantum confinement at a nanoscale material on the electrical, thermal, and optical properties become significant about this sign, okay, for the quantum confinement. I'm not sure, maybe you already study about quantum confinement in, and we have one subject is called the optical and uh, electrical, optical and next property. I think optical and electrical property. Yeah. Subject. Okay. And one more thing here at a small size, so it will be reduce imperfection. Okay. So for the bigger size, of course, it will contain more impression, such as vacancy, dislocation. Okay. And even also it contains micro crack. Okay. So when we reduce the size of the material, uh, especially to nanoscale, so it can reduce or even remove imperfection. So the property will be different to the bulk material. Okay. One more thing here is about nanoscale material have very high fraction of the atom on the surface, this is very important. This will decide the property and electrical or physical, chemical, and mechanical property of nanoscale material. Okay, so why I can explain to you. For example, here, if you have one cubic with the size 1 centimeter, 1 centimeter, so the surface area is 6 square centimeter. So if you divide this cubic, you can cut it. Okay, you can cut it into a smaller size. Okay, for example, you cut it all the side of the cubic into 1 mm. Okay, 1 mm. So the surface area of all this, okay, cubics become 60 square centimeter. Okay, so now 10 times higher, even also from the same, okay, the same object when you cut into small size, so the surface area will increase. So if what happened if you cut this object into small size with 1 mm cube, okay, so the surface area can increase into, okay, 60 million square centimeter. You can see, okay, image is extremely large surface area of nanoscale material. So we call it this kind of specific surface area. It means the total area of a material per density. For example, you have 1 gram of uh, of gold. This cubic gold, 1 gram. So if you cut it into 1 mm cubic, so you will have 60,000 centimeter, 60 million, sorry, centimeter, square centimeter per gram. Okay, so 1 gram you can make the surface area become. Okay, so you can course the full full football stadium. Okay, so you can imagine this very large surface area when it's become a scale material. Okay, this the first one is about centimeter cubic, but when have only 6 square centimeter, okay, but you scale down to nano, okay, it can be 60 million, okay, square centicubic, okay, that's it make nano scale materials special and have different property compared to bulk material. Okay, so go back to the surface area, atom on the surface area. So why is this important? As you know that for when the material is contact for the chemical reaction happen, so it will happen on the surface of the material. So all the atom on the surface, it will play very important role in the interaction between the particle. Okay, so if have more atom, okay, on the surface of area, so it means that the reaction will takes place faster and stronger. Okay. Yes. And that is why. So this also will determine, okay, physical and chemical and mechanical property of material. Okay. And as people said here, so the atom on the surface of the particle is very different from the one located inside the object. It means that only the atom on the surface will be active, okay, because it's the first atom in the context, okay. So the atom, the surface atom, become very important for the whole chemical reaction, okay. It will happen at the atom on the surface, okay. So do you understand this? Anyone about, you understand about this atom on the surface and make the different property? Do you understand? Yeah. So no problem, right? Okay. Maybe we break for 50 minutes. Is this okay? So we come back to the lecture. Hello? Everyone sleep?
Yes. I'm here.
Sleeping?
Yes.
Okay, so we take break for 50 minutes. So you can come back to the lecture at 15. Okay. Okay, so we go back to the lecture. Okay. Okay. Oh, this. Okay, so because they have very high fraction of atom on the surface. Okay, so it will determine on the chemical property, and also it will change the physical property of the nanoscale material. Okay, here you can see that at nanoscale material, the band energy also can be changed. Okay, and the density of state also change. So this will affect on the electrical property of the material. Okay, at nanoscale material. Okay. Okay, so we will go a little bit about the history of nanoscale material and nanotechnology. Okay, so go back to the 20th century. Okay, so for the first discovery of semiconductor in 1950. Okay, so this based on transistor is open the doors for minimize and integration of this device in the first chip. Okay. Okay. So in the same decades, the idea about huge information storage capacity of material were presented by Richard Feynman. Okay, so he's the first person, okay, mentioned about something like nano scale material when he talked about his lecture in Caltech Institute of Technology in USA. Okay, so he talked about something like divide to all the give or store information in a small particle, So divide to small particles, so it's more information can be stored. So in that lecture, it's very famous lecture. It's open for the new road for nano material and nanotechnology. Okay, so Richard Feynman, he got Nobel Prize in 1965. Okay, this is a physics, okay, a scientist. Okay, he very famous, very famous. Okay, and also very interested person. So in 1959, okay, Richard Feynman speaks or lecture at a context. He talked about there is plenty of room at the bottom. So this open for new technology. Okay. And in 1969, okay, so I just give you some milestone of nanotechnology and nanomaterial. Okay, so this is some milestone. Okay, in 1969, okay, invention of surface force apparatus SFA. Okay, this is very important for nanomaterial and nanotechnology. Just the human can observe, okay, at the nano scale, okay. When they invent this kind of equipment or this kind of apparatus, okay. And in 1974, okay, Japanese professor Norio Taniguchi gave a name to the new field in a scientific paper titled "On the Basic Concept of Nanotechnology." So from that word, people use the word nanotechnology. Okay, so from 1974. Okay, so people start to using nanotechnology. Okay, and in 1981, okay, invention of scanning tunneling, okay, microscope, SDM, okay, by Roller and Billing, okay, at IBM Zurich. So this he already also got or he awarded by Nobel Prize in 1986, okay, for his invention. Okay. And also one of the very important events that in 1985, Fuller's, or people call it a bucky bone. Okay, it's similar to our bone, but at the scale of nanomaterial. Okay, were discovered at Rice University, and the scientists were awarded in Nobel Prize in 1969, okay, for this invention. Okay. Before that, we just look at carbon. You see, some people burn, okay, burn wood. Okay, after finish the burning, okay, you can you will got the carbon. So it look very, it look black, okay, look ugly, but under scientific or under yeah, the people can make it become very nicely, okay, under nanotechnology and under nanomaterial scale. And in another very important discovery in nanoscale material is in 1991, okay. The carbon nanotube CNTs were discovered, okay. So nowadays the carbon nanotube are very famous nowadays, and of course this kind of synthesis carbon nanotube also quite complex, okay, process, and not everyone or not every country or not every institute or university can successfully synthesis carbon nanotube, okay. Okay. And in 2004, many journals about nanotechnology and nanomaterial established, for example, Journal of Nanotechnology, Nano Leicester, Journal of Nanoscience and Nanotechnology, okay, and many other nano journal, okay. So it means that the people are very, very interested and in put a lot of efforts on nanomaterial and nanotechnology. Okay? And recently in 2010, okay, Andres and Kim and Konstantin Novoselov, these are two Russian scientists. This is two Russian scientists. They working at Manchester University in England. Okay, they awards Nobel Prize in 2010 for the work is groundbreaking experiment regarding to two-dimensional material graphene. Okay, so this is the first time, okay, people can extract as one the material as one layer of atom. Okay, atom, one layer of atom. This one layer atom. Okay, it's not a thin film. Okay, thin film it can several nanometer or several or can be 10 or even hundreds nanometer, but for the graphene is only one atom layer. Okay, so that's why say the first, okay, scientists, they are the first scientists can make it make from graphite, okay, from graphite into a graphene layer in one atom layer. So they won the Nobel Prize in physics. Okay, that is for some milestone in nanomaterial. And here is some image for the history of nanomaterial and nanotechnology. Okay, yeah. Of course, you can go further in before 1950, but from 1950 to now on, nanotechnology and nanomaterial is more active. So we're starting from 1950 review from 1950. Okay, start from Freeman when he delivered a speech at Caltech Institute. Okay, so following by other scientists to discover the apparatus for observing nano scale material, and recently for the discover on one layer of graphene. Okay, so these is two scientists from University of Manchester, England. Okay, from Russian, but working at England. Okay, they got Nobel Prize for this one layer, one atom layer of graphene. Okay. Okay, we will go to the next topic. Okay, to classification of nanomaterial. Okay, so what kind of nanomaterial we can have, or how we can classify nanomaterial? Okay, so we can classify nanomaterial based on their dimensionality or aspect radiation ratio. Okay, aspect ratio. So in this case, we classify based on aspect ratio. So we will have 4 different kinds of nanomaterial or nanoscale material. The first one we call is 0D or 0 dimension nanoscale material. And with the second one, we have one dimension scale, one dimension nanoscale material, and we have 2D and 3D. Okay, 3 dimension. Okay, so this is how we can classify. Okay, classify the nanomaterial. So for 0 dimension no object have a nanometer feature sign in every direction. So this should be quantum dots, nanoparticle, and photons at the ball. So in every dimension, it should be, okay, it should be in nanoscale. Okay. For example, x direction, y direction, z direction. All this direction should be in nanoscale. Okay. So this should be quantum dots. Okay. Nanoparticle or photons. Okay. Photon. Okay. Nanoparticle. Okay, for one-dimensional objects, they have a nanoscale, a nanometer size in two directions, but a larger. Okay, so it means it will have in a smaller in two direction and bigger in the last direction. Okay, so we call it micrometer in the line in the third direction. For example, the layer. I'm sorry, this is for the wire. Okay, the wire. So it means x and y direction should be in nanoscale. Okay, but the z direction can be in a micrometer. Okay, for example, nano wire. Okay, nano for the carbon nanotube. Okay, so it should be smaller in two directions but bigger in the last direction. Okay, should be the wire. Okay. So the next material is what we call it two-dimensional object. So as atomically thin sheet of a material, so that should be layer. Okay, for example, graphene. Okay, so it should be a layer. Okay, thin sheet. Okay, for the last one, it should be a 3D object should be for nanoporous and nanostructure material. Okay, so it means the material with porous, nanoporous inside. Okay, so here some schematic illustration for different kind of nano scale material. Okay, we have 3D. Okay, and in all three directions. Okay, we have 2D, so it's very thin a layer. Okay, for example, graphene, and 1D, so we have two direction small, or we can call it the diameter in nano scale, but the line, okay, can be in micro. And we have 0D. Okay, this one for particle. Okay, this is a nano wire. Okay, we have nano wire. This is this picture is, or this image is for nano scale particle. Okay, 0D dimension. And this is illustration for 3D nanoscale material. Okay. Here is a TEM image for 0D, or what we call is a nanoparticle. Okay. And here is for 1D single wall nano carbon tube. Nano carbon tube. Okay. So this is 1D material. Okay. So here we have 2D for graphene. Okay, this material now become very famous and have extraordinary property. So many scientists and institutes they focus on this kind of material. Okay, it's a process very special property when it's one or it a single layer the atom. Okay, And the last one here is for 3D nanoscale material. Okay, one more thing I want to add you here or remind you here. Nanoscale material is can be metal, okay? It can be a ceramic, it can be a polymer, okay? Please take note that one. Okay, so here is 3D, okay, 3D nanoscale material. So this this kind of nanoscale material is very important for application. For example, in human body to replace the bone, because our bone is the structure also contain porous microstructure, nanoporous structure. Okay, so as people also study this kind of structure to replace the our body bone. Okay, very important. So for graphene or carbon nanotube nowadays is very important in electronic devices, okay, application. And nanoparticle here also very important in many kind of application. One example, for example, in I already mentioned you when it as material at nanoscale, so it have very high surface of volume. Okay, so example they were used to treat water, okay, polluted water in the river. Okay, so they can use this kind of nanomaterial. So this will have very high surface, so it can the chance for this interacting with other dirty very high. Okay, so they use nanoscale material to treat the polluted water. For example, in Tolic River in Hanoi. Okay, for the next session, we go to the formation of nano material. Okay, so how nanomaterial can form. Okay, and so we have two approaches to form, okay, nano scale material. The first approach we call is top-down methods. Okay, this involves to mechanical grinding. Okay, for example, you use some mechanical to make the particle become smaller and small to nanoscale. Okay, so this kind of approach can slide down particle or object at micrometer to about 10 nanometer. Okay, so we call it top-down methods. For the second approach, we call it bottom-up methods. So this approach can synthesize or fabricate nanomaterial at the scale about 1 to 100 nanometer. Okay, so especially is about synthesis, we call it self-assembly. Okay, so this is the methods or the approach to formation of nano material or nano scale material. So both of these approach can precise control of nanostructure. Okay. Okay, anyone hello? And understand about this? What I'm talking? Is it too fast or is okay?
It's okay.
It's okay. Okay, thank you. Because I'm just talking, I feel that I'm talking alone. Okay.
Maybe, excuse me, maybe your fan. It's too loud.
Okay. So I will turn off this. So it's too noisy, right? Okay, so we have two approach. Okay, we have two approach to form nanomaterial. Okay, it's more detail about this two approach. Okay, this image or this photo for illustration of top-down methods. Okay, it means you make you break down some a big object into small particles. So we call it the top-down. Okay, methods. Top-down approach or top-down methods. Okay. On the right hand side, okay, photo is about some also some top down, okay, top down image or material we use top down methods. Okay, A and B is nano laser, okay, can generate by direct writing with AFM tip. Okay, you can see that people can write the laser at nano scale. Okay, you can see here this scale is 100 nanometer. Okay, so 100 nanometer here. Okay, so we can try it at nano. Okay, and the second letter IBM nano. So this made of silicon oxide wafer. Okay, wafer, and this structure after etching. Okay, by this letter achieve. Okay, after etching remove the oxide. Okay. The last no just in pictures image in the picture see here a high spec ratio silicon purer which created by patterns generated by gallium ion implantation. Okay, so this you can see this very small, okay, like nanorods. Okay, nanorods. Okay, you can see here. In fact, you can see this kind of pattern in the use for cooling, heating, cooling in the PC. Okay, PC. Yeah, they can use this kind of heat exchanger. Okay, for cooling. But here is at very small scale. Okay, in nano scale. Okay. So here what we call is the top down. Okay, the top down. Top down methods. Okay. Okay, for the top down methods or top down approach is referred to slicing or milling. Okay, milling is mean you have you put some material at micro scale into a container and you put the ball, steel ball or oxide ball together with the powder, and then you put in one machine and it will rotate and it will grinding or sliding the powder into nanosite. So what we call is top-down methods. Okay, this is get nanosite particle. So we this kind of bone milling machine. Okay, all we call is a high energy bone milling machine because this machine can rotate with very high rotation speed, with very high rotation speed. So the collision or the impact between ball and powder inside of this container, so it will refine the powder into nano scale particle. Okay, so what we call is bone milling or mechanical alloying methods. Normally it called is mechanical alloying methods. So later I will teach you about this kind of fabrication methods. Okay, so this is top-down methods. We have from bulk material of from a big object. So we slide into small pieces, okay, or even we can grind down it into a powder or nanoparticle, okay. So this we what we call is top-down methods. Okay. However, the biggest problem of this top-down methods, okay, approach is the imperfection of surface structure, okay, because it's using mechanical force, okay, mechanical force to break down the particle, okay, so it makes the particle surface will imperfection, okay, imperfect surface, okay, we can often the particle with imperfect surface structure. Okay, so and significant crystallographic damage, okay, to the process of pattern. And one more thing is when we're using a top-down methods, okay, is also make some contamination, okay, contamination from the grinding media. For example, because you're using this bone and this container, so during bone milling, okay, the ball is rotated with high rotation speed, and it's impact to the wall of this container, so it will also grind out of material of the container, okay, so that is also contaminate the material also. So this is a big some big problem with the top-down methods, okay. Of course, scientists or researcher can have some way or some technique to prevent this kind of disadvantage, okay, or this problem, okay. Okay, the second approach is bottom up, okay. So this refer to the build up of a material from the bottom. It means we build object from small particle, okay, or from atom by atom, okay, and it become atom by atom and lecture molecules by molecules or cluster by cluster. Okay, so this is the approach we call it bottom up. Okay, so we have bottom up. We build the object from atom, okay, by atom. Okay, so atom and molecule is will combine together to build a bigger cluster. So cluster is combined together to particle. The particle combine. The particle here is nano scale. Okay, so the nanoscale is combined to the object, okay, the bulk material. Okay. So here is illustration for bottom up and top down fabrication. Okay, so for this direction is for bottom up. Okay, it's very good example in the living. Okay, our living. Okay, for what we call it a self organization. For example, for the living organism, okay, living organism, okay, from a DNA, so it's become together, it's mixed, and from it will build protein, okay, protein will build cell, okay, building cell or organism, okay, and from that one is will build up our body, okay. So this kind of illustration is for bottom up approach or bottom up methods, okay. Okay, so for example, in exam or multi-choice, we can ask you a question: what is scale? What is nanoscale material? Right. So we will give you some answer. For example, is from 1 to 100 nanoscale, from 1 to 100 nanometer, or from 100 to 200, or so on. So that's that kind of question can be come out in the exam. Okay, and we also give you, for example, what are the top down, okay, approach. So we will give you some answer, so you have to choose the correct answer. Okay, that's can be come out in exam. Okay, so that is the question, how the question can be. Okay. And yeah, that is an example. So we go to the next section is about property of nanomaterial. Okay, so we will see how a property of nanomaterial is different from a bulk material. Okay. Okay. So again here, the reduction of a material dimension. So it has pronounced effects on its physical, mechanical, and chemical property, okay, as I mentioned earlier. In the most cases, thus the value of these property are very different from though in bulk. It depends on the size, okay, the size of material, or the size of or the scale of material. Okay, and it also depend on, or what we can say, it can be controlled by morphology of the nanomaterial. So this two kind of factor is effect on property of nanomaterial. Okay. So morphology here is can design the property. For example, is 1D, 2D, or 3D material, which it will possess a different property. Okay, even it's the same material, or it. Okay. So for different morphology will give different property. Okay, so I will briefing you the first property of nanoscale material. Here is surface area to volume ratio. So this is also very important, or this kind of property distinguished from bulk material. Okay. The surface area to volume ratio. So it means we will calculate for a certain volume, okay, or for a specific volume, how much the surface area, okay. For example, one cubic centimeter. So we will calculate how much, okay, surface area for a certain nanoscale material. Okay, so yeah, so due to the small dimension, okay, nano material have extremely large surface area, okay, to volume ratio, okay, as I showed you earlier. Okay, when we break down 1 centimeter cubic, okay, so into nano scale, so it have very large surface area, okay, but the volume will be the same, okay, but the surface area will be extremely increased, okay, the same volume or the same weight, okay, the same mass object, but when we scale down, okay, so it will give you extremely large surface area, okay. The large surface area to volume ratio of nanoparticle open many possibilities for creating new material and facilitating a chemical process. Okay, this is very important, and I explain to you because the particle will contact in the surface. So nanoscale material have high fraction of atom on the surface. So it will become very, very active at nanoscale. Okay, material become very, very active. Okay, one very simple example for you. When you put sugar in the water, okay, if you have a big particle, so you have to stir, okay, stir, take a little bit long to dissolve all the sugar into water, but you have, okay, small, very fine or small particle of sugar, so it's easy to stir and it's very fast to dissolve sugar in the water. Okay, so similar for our nanoscale material at a small scale, so it's become very active. Okay, very active. Okay, so so the reaction of nanoscale material become very fast, right? Because it have very high contact surface area. Okay, so that's why it become very active material. So that's why the metallics, okay, metallic or we call metal, okay, metallic nano particle can be used as a very active catalyst. Okay, yeah, you can use as a catalyst also. Okay, and of course for the chemical sensor, okay, this is also very important. Okay, when the material or devices, devices, or we call it sensor device, okay, made from nanoscale material, so it will very, very sensitive to detect the gases, okay, detect the gases and other material. Very sensitive, okay. It means that it's easy to detect in very, very small amount of gas or material, okay. Okay, we can have a sensor to detect light, or we can have sensor to detect some very toxic gases at very, very small amount, okay. So based on this kind of nanomaterial and nanotechnology, we can do it, okay. Okay, so chemical sensor from nanomaterial particle and nano wire, okay, can enhance the sensitivity, okay, and sensor selectivity. Okay, sensor selectivity is mean you can select more, okay, more matter. Okay, for example, you can detect a hydrogen, oxygen. Okay, many very accurate. Okay, you can detect many more. Okay. So, okay. So here example how we scale down. Okay, scale down the object from the cubic with 1 centimeter to nano centimeter. Okay. So for this cubic have 6 centimeters, 6 square centimeter. So if you scale down, okay, you divide into 8, okay. So surface area increase to 12, okay. And if you divide to 64, okay, it's the same mass, okay. For example, 1 gram, okay, for the same volume, okay. But you divide to smaller particle or smaller pieces, okay. So you got more surface area, okay. 64. So you have 24 square centimeter. And if you divide into 100 nanometer, so you have 60, okay, 60 square meter. Okay, so if you scale down to 1 nanometer, as I showed you earlier, so you can get 60 million, okay, square centimeter. Okay, so this is very, very important for a nanoscale material. And so the surface area divided to volume. So what we call it a specific surface area. Okay, so it will proportional to reciprocal of radius. Okay, it means that specific area increase when, okay, the particle become smaller or the radius of particle reduce. Okay, okay, so this is this, okay, will give you the relation between a specific area, okay, to the radius of the particle. Okay. So please also take note this. Maybe I also ask you the question: the relationship of surface area, a specific. I don't know. You understand the specific area or not, or specific strength or specific. Yeah. So anyone can tell me what is the specific of strength of material strength? Anyone? In our class, Hương, right? Hương, I see her very active in this class. Okay, Hương, what can you you know what is the specific strength of material? Do you know?
It's the strength of material. Is the strength of material divided by the density.
Okay. Yeah. Thank you. It's yeah. It's correct. It's right. So it's strength, specific strength of material can as the strength divide to density, or we call it divide to mass. For example, how much? For example, 100 megapascal. For example, aluminum have 200 or even 1,000 megapascal per gram. So this value will give you the image to show you how the material is strong and the weight is. It means we want to have, okay, we want to have the material have strong strength and low weight. Okay, so based on this kind of value, people can easier to select, okay, select the property for design. Okay, for design, especially in aerospace and in automobile, we want to have the material have high strength and low weight. Okay, so from the same, okay, same mass or same volume, but we can get more, or we can get higher strength, or we can get higher surface area. Okay. Okay, that is we call it a specific strength or specific surface. Okay, volume. Okay. So the total surface energy increase with the overall surface area. So it means that when the surface increase, so the energy surface also increase. Okay, increase. So remember. So it means the energy proportional to the surface area. Okay. Of course, when the energy of the system increases, so the system will become unstable. So this is also the problem in the synthesis of nanomaterial. Okay. Okay. So the total surface energy increase with overall surface area, which is in turn strongly depend on the dimension of material. Okay. Table 2.1, okay, this table indicates how the specific surface area, okay, and total surface energy of 1 gram of how we call it, sodium chloride, okay, vary with particle size, okay. So here is the size from 0.7, 0.1, and to scale of nano, okay, scale of nano material. This is 100 nanometer, okay. So you can see here the total surface area will increase with decrease of the dimension of the particle, okay. You can see it's increase of very high, okay, surface area. Okay, the total H, and here you can see the fourth column here is the surface energy. Okay, so it will increase from 7.5, okay, with minus power 10 minus 5 into 560 joule per gram. Okay, so it's increased very much. Okay, very much. Okay, when it's under a nanoscale material, okay, under nanoscale, so the energy will increase very much. Okay, so of course, because at the nanoscale is the surface or the system energy of system increase, as I mentioned, it will be unstable. Okay. Okay, so here for the example. Here also, so this picture present to you or show you the atom chain, atom, the surface atoms. Okay, surface atom. It means the atom on the surface of particle. Okay, okay. Chain width. Okay, the dimension of the particle. Okay, this so for palladium. Okay, cluster. Okay, palladium cluster. Okay. So here is diameter. This is surface atom. This is percentage. Okay. So you can see. Okay, here with surface atom here 63 micrometer. The percentage is almost zero free atom on the surface. Almost. Okay. It's very small, so we consider it's a zero. Okay, very small. Okay, you can see very small. And when the diameter of the particle reduce, you can see it go down. Okay, so the surface atom percentage of surface atom will increase. For example, here, if the particle have the size about 7 nanometers, so the surface atom will be 35%. Similar for 45% for 5 nanometer and 75% if we reduce the particle to 1.2 nanometer. So you can see that by reducing the particle size, we can increase the percentage of surface atom. Okay. Okay. So this is for the surface atom per unit of volume for the same volume. Okay, for the same volume. So what we call here the ratio of surface atom, okay, to the interior atom chain, okay, dramatically if we make it smaller, okay. Okay, I think it's the time already up. Okay, so we stop here. Okay, so next week we will continue. This okay?
Yes.
So anyone have a question about this lecture or anything about this course? Okay, if you don't have questions, so the monitor, okay, please next week give me the group, okay, name of the group. We have 5 group, okay. So you can arrange the group member by yourself, okay. So I don't interfere in this, okay. So you just arrange by yourself, okay, and give me the name of the group in the next week. Okay. Okay, if you don't have questions, so we finish here. Okay, you can leave. Okay.
Yeah, thầy ạ.
Ok, bye bye. Chào các bạn nhé. Các bạn có thể out ra rồi.
Dạ,
Yeah,
thầy.
Ok, chào các bạn.